And turn, as Bob Seger would say. Didn't Metallica do that too? Turn the page.
Yes.
Turn to page
2,
3.
1.
I know. Somebody stepped on a Three Musketeers bar and the custodian thought it was the dog had an accident. Okay, this is 5.1.
Hold up.
This is in your notes packet that you get to keep forever and ever and ever till you die.
Go past the one for Keon.
Yes. Just attach them, staple them to the packet when you turn them in. Equating graphing polynomial functions. Polynomial functions, you ask. What is a polynomial function? Well, I'm going to tell you. A polynomial function is a function in the form of f of x equals a sub n x of n plus b a sub n minus 1 times x of n minus 1 plus dot 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 a sub 1x plus x of 0. Now, what does that mean, you ask? Now, we've been working mostly with the quadratic function, right? Standard form of our quadratic function is ax squared plus bx plus c. Okay? All of this stuff in here, all of this mathematical terminology, it's just the coefficients of our x's and our x's themselves. So if you look at the chart here, our constant term, like our c in the quadratic one, is f of x equals a sub 0. Don't get hung up on all of this terminology here. Okay, just know that the linear equation, well, you know what that is. You worked with it as y equals mx plus b, right? That's a linear equation. Standard form is y equal all of this. Our quadratic form was y equals ax squared plus bx plus c. That instead of using b and c, they're just using different subscripts for a. That's all they're doing. They're substituting that in for a b and c. Okay? If I have an exponent or degree of 3, I have a cubic polynomial function, and that is all of this mess. If I have degree 4, it's a quartic polynomial function. If I have degree 5, or 5 as an exponent for my variable, it's a quintic polynomial function. And anything with degree 6 or more, we just say a polynomial function with degree 6, or whatever degree it is. Now, you may be asking yourself, well, when is an equation not a polynomial function? Well, it's not a polynomial function if I have x in the denominator. It is not a polynomial function when x is in the denominator. Now you're probably saying to yourself, well, when can x be in the denominator? Well, how does that represent it, though? Now, that is not a polynomial function. Okay, not a polynomial function when x is in the denominator. Or, and I can make x in the denominator of a fraction by doing what?
Multiplication.
If I have x here, how can I make that in the denominator of a fraction?
Divide by.
Close. I know what you're thinking of. Make it a negative exponent. That's 1 over x, right? Right?
That's when it's
Right.
not when it's in the denominator.
So when you have a negative exponent on the variable, because if I have a negative exponent on the coefficient, or a, b, and c, if I have a negative coefficient on a number, say 3 to the negative 1, that's still a number, right? It's 1/3. Oh, the only time it's not a polynomial function is when I have a negative exponent on a variable. It's okay to have a negative exponent on a number, but not a variable. With me? Their values. Yes. Okay, let's look at part 1 here. We have some polynomial functions, maybe. If they are polynomial functions, we're supposed to put it in standard form or from highest degree to lowest degree. Then we're supposed to figure out what degree it is, the type, and then the leading coefficient. So, number 1, first of all, is it a polynomial function? Do I have x in the denominator anywhere? No, so it is a polynomial function. Let's put it in standard form. What's my highest degree?
3x, negative 3x.
Negative 3x to the 4th. What's my next highest degree?
2x.
1/2 x squared, and then my last degree, 7. And that's actually x to the 0. Okay. Sorry, because it goes from highest degree to lowest degree. X to the 4th, x squared, and actually this is x to the 0. We just don't put it there.
Right.
It's degree 4, and what's that called? Quartic. Quartic. Degree 4 is quartic. And what's my leading coefficient? Negative 3, right? This is the leading coefficient here. Okay, number 2. Is this a polynomial function? Let's put it in standard form. Hey, look, it already is. What's the degree?
3.
And what type? It's from cubic, man. And leading coefficient? Number 3, polynomial function. Yep. Let's put it in standard form. Yep. Yep. What degree is it? And it's called a quintic. Leading coefficient. 4. Is it a polynomial function? Well, do we have x in the denominator anywhere? No, so it is a polynomial function. What's the highest degree? 2. So my pi x squared goes first. Then I have a negative 0.5x. And then I have a negative square root of 2. Degree 2, that's called a quadratic. And what's my leading coefficient? Pi. Yeah, Martin, you have to write it out until it stops, okay?
All right.
Probably. Yeah, I don't know if I could stretch it till Thursday. Maybe Wednesday. Okay, now more funner stuff starts. But okay, so the standard form is highest degree of the variable to lowest degree of the variable. The highest degree of the variable here is 2. So that goes first. Okay. Then there's a 1 here, so that goes next. And then there's no variable there, so that's last. Okay. And then the leading coefficient is nothing more than the first coefficient. Okay. All right, number 5. This is where the more funner stuff starts. Remember, actually, this is the same worksheet I used in Algebra 1. You guys should have did this already. All right, so we have a polynomial function here because the f of x equals 2x to the fourth minus x 8x squared plus 5x minus 7, and you're supposed to be evaluating this at x equals 3. Well, in mathematics, we don't like to write anything English language whatsoever. We just like to use symbols. And this is what we call function notation, right? Because of the f of x. Well, instead of writing all this stuff, can be evaluated when x equals 3, we just use the f of 3. And then what we do is we take that 3 and we substitute it in whenever there's an x, wherever there's an x. Okay?
Okay.
So, in fact, I wrote it out for us here. I like to put parentheses around the x's of where we're going to substitute so I don't make a mistake when I put this in a calculator. So everywhere I have an x, I'm putting parentheses. That way I won't screw this up when I put my substitution. Yeah, it's already written out. I'm just doing it for teaching purposes. And I'm supposed, now this is what my x equals. So I'm going to, instead of x, I'm putting in my 3. Now, if this you can put in a calculator. As long as you put your parentheses in there, it will work. Right? You should get 11, I think. C2 parenthesis 3 raised to the fourth minus 8 parentheses 3 raised to the 2 plus 5 parentheses 3 tangent minus 7. Should get, like I said, you should get 98.
It's about the calculator.
Now, there is a way. There is a way to store this in your calculators. I have no idea how to do it, so if you want to go do it online, I don't care. Yes. Uh-huh.
How does the calculator know when to stop making an exponent? Because I know on some of them it actually moves up to a tiny letter and then back down.
Yeah, it's a good question. It depends on how many updates, if you updated your system on the calculator.
So
if you have a more current version on your calculator, it will stay in the exponent until you hit the right arrow, and then it'll pop it out of that exponent. But I haven't updated this thing in years, and so after the first letter, unless it's in parentheses, it's out of the exponent. I'll have to take a look at your calculator. If you're using one of the class, if you don't put the parentheses in the exponent, like say you want to raise it to the 3x, you don't put the entire 3x in the parentheses, and you just put 3x, it will only think that your calculator is being raised to the 3. Okay?
So if you have 4,
Put parentheses in it. Yes. Yes.
All right. Because I always wondered.
But it's weird because, I mean, even if I took our calculators and updated all of them, it would change it to the new one. And then it would automatically, you would have to use the right arrow key to get out of the exponent. All right, let's do some examples. Are you ready? Are you ready, kids? The f of x, let's see, x equals -4. So we have to do the f of -4. And again, wherever I have an x, I'm going to put parentheses. Okay, this one's easy. I can do this in my head. -12 minus 5 is -17. Okay, 7, we're supposed to do the f of 1. So I have 3 absolute value 1 minus 2. So I have 3 times the absolute value of -1, which is absolute value of -1, +1. +1 times 3 is 3. Did I forget? How did I? Did I forget a parenthesis or something? Didn't I? Oh, number 8's 11. Okay. The absolute value of -1 is +1. +1 times 3 is 3. Okay, number 8. I bet you number 8's 11.
Nope.
The G, what, -2? I gotta get some water.
Wow.
So I have 4 parentheses squared plus 2 parentheses minus 1. And I'm putting in -2. By the way, if you don't put negative parentheses around a negative number raised to a even power, you will get the wrong answer. So I have 4 times 4 minus 4 minus 1. 16 minus 4 is 12 minus 1 is, hey, look at that. What do you know about that?
I call that game by.
So there's function notation, okay, that you did back in Algebra 1. Now, we're going to take this and have more fun, make it more funner. No, we're going to take this into Algebra 2. Turn it over. We're going to raise it to the next level. Okay. Okay, the next level is what's called end behavior of a polynomial function. What do you think end behavior means? Hey, what happened to our function at the end?
They die.
All right, and the way we read this.
They don't
Okay, so it says every time you're doing end behavior, the first thing you're going to do is you're going to put this template down. The f of x, this is approach. The side arrow means approaches. Blank as x approaches negative infinity. And you're going to write f of x or y approaches blank as x approaches positive infinity. So as soon as you see the word, okay, go ahead and describe the end behavior. You're going to write this template down because your job is to fill in the blanks. Okay, now what does that mean? Well, let's put this in layman's terms. As x, now negative, you think about the x-axis. As x goes to the left, right? As x goes to the left. What happens to y? And then you're going to fill that in. Now it changes. It changes. It depends on the function, right? And then this way, as on the x-axis, as you go to positive infinity, you're going to be looking at when x goes to the right. Okay, that's kind of like the layman's terms. That's non-mathematical terms. Mathematically, we're going to say as x approaches negative infinity, the f of x approaches, and you fill in the blank. So, I don't like these because there's no graph on them. I would prefer to do them with a graph. So let's do number 10. And let's describe the domain and range and then the end behavior. So I already told you got to do the end behavior. So what are you going to do? Well, you're going to put in your template. Okay. Whenever as x approaches negative infinity, the f of x approaches blank as x approaches positive. So whenever you see end behavior, you're going to put that down.
All right.
Okay? So now we're going to go back and we're going to sketch our graph. Well, since you guys were so good last semester, you can easily graph this function, right? This is the parent function with a transformation of up 3. In other words, you're going to grab your calculators and you're going to put it in there. Okay, so we have x squared plus 3. I'm going to graph it, and you get a parabola that's 3 up. And if you don't remember that, do your chart. Second graph. Let's get some numbers here. There's my vertex, 0, 3. I know it's the vertex because 4 start to repeat. So 0, 3, 0, 3, 1, 4, negative 1, 4, and there's my parabola. Or as we mathematicians call it, parabola. And what's my domain? What's the domain for all parabolas in this class? Negative infinity, positive infinity. And what's my range for this parabola? What's my least y value? 3. Does it include 3? So I'm going to put a bracket. And where does it end up? Which always gets a parenthesis, right? Now, let's describe the end behavior. Now, we're looking at our x-axis. As x, remember layman's terms, as x goes to the left, so as x goes to the left, what happens to my y? goes up to positive infinity. Are you with me? As x values go to the left or negative infinity, my y values go to positive infinity. All that for that. Yeah. As x goes to positive infinity, or as x goes to the right, what happens to my y? Goes up to positive infinity. No, depends on the function. Now, okay, questions? Number 11, let's see if we can do this a little faster. Again, we're going to have to do end behavior, so we might as well write the template down. In this end behavior, we're going to be doing quite a bit of, so you might as well get used to writing all this crap down. Okay, we got an 2x fourth, so this is going to have a parabola with a bump in it.
Wait, can we just write down so that
Can you what? It should be the same because there's no negative sign in front of my parabola here.
so one.
I would, yeah, these are going to be the same. They're going to be both positive. But let's just do it for teaching purposes. All right, so let's put in here 2x to the fourth plus 3x cubed plus 1. Going to graph it, and it's going to be a parabola with a bump. See it? It's got two, these are called actually local mins. So let's graph this thing with some points. Let's see, we can use, let's use negative 2, 9, negative 2, 9, negative 1, 0, 0, 1, 1, 6, and then 2 way up there in your homework packet, the bookwork. All right, so there's my graph. It's my graph. Okay, what's my domain? What's my range? What's my least y value? Look at the y-axis. Where's your least y value?
Negative.
No, that's the x. 0 is your y. And it goes up to positive infinity. And as x goes to the left, what's going to happen to my y? It's going to go up to positive. As x goes to the right, my y goes to positive. Now I want to do number 12 because it's different. It's a odd parabola. It's an odd polynomial. Okay, so let's put in the 2x cubed. Okay, 2x cubed minus 4x squared plus 3x minus 5. Graph it, and I get this funky thing. I said funky. 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 F-U-N-K-Y. Funky. Okay, let's graph this. The book, the book pages are in your practice packet. Yep. Okay, let's see. We can do -1, -14 is going to be way down here. 0, -5. 1, -4. Oh, that's -2. Here, it should be this. Yeah. There. What's my domain?
We don't know.
Yeah, it's the same because it's out continuing forever and ever and ever. What's my range? Range is the same thing, right? Now we have to do end behavior. So let's write down our template. Okay, as x goes to negative infinity, so as x goes to the left, it goes to, my y goes to negative infinity. And then as my x goes to positive infinity, my y is going to go positive. What?
On the end.
You have to put down everything.
I'm lazy.